Hi everybody, Stu AG6AG, and today we're going to cover a topic that I've been getting questioned on quite a bit from the local clubs out here regarding using a tinySA to actually check a radio. In other words, hook a radio up to it. To do that, of course, you need one of these, and this little gem right here is a 50, count it, 50 dB attenuator that handles up to 1,000 watts. Okay, now hook it to your tinySA, and at 1,000 watts, you'd be pushing this pretty hard, and you'd probably blow up your tinySA. You wouldn't blow this up, but that's neither here nor there. This is probably more than safe to 100 watts. Your mileage may vary though, and we open this thing up and we talk about it, and we show how to set up for it, we show how to test it. We're also going to show you how to set up the tinySA to actually read proper readings coming out of the radio, so you actually see the actual dB ranges that are coming out, not just that it's coming out and differences from noise level and things like that. So this video, actually, after I watched it, after putting it together, I realized that there's going to be more videos on this subject, not necessarily using the NanoVNA and the tinyVNA like we did in this video, but showing how you kind of calibrate things up so these numbers work out. And with VHF, when you're trying to check harmonics, how you verify that the readings that you're getting in the harmonics are adjusted mathematically in your notations so you don't get the wrong readings on paper. Okay? Anyway, enough said about that. I've talked enough about it. Let's go ahead and jump in and start looking at how this is done, huh? Oh, and by the way, yeah, I got to ask, do me a favor. If you like my videos, click the subscribe button. And don't forget to like my videos. If you really like it, give me that thumbs up. It puts my videos in front of more people that could really benefit. All right? So with that, let's get going. All right, well, this is the item I've been talking about. Now, I am going to open it up, and real quick, I want to show you the inside. And there you go. Look at that. Let me zoom in a little bit on this if I can. Let's see how this works. I'm going to try to get down in here a little bit. Let's get my smiling face out of the way. All right. So if you look down in here, basically all we have is we have a ground, we have a crossover right here, and in from the transmitter out to a dummy load. Then all these resistors constitutes the attenuation that comes out of this port here that goes to the tinySA or any spectrum analyzer for that matter. This is actually configured. This is set up to do a 50 dB attenuation up to about 1,000 watts. Okay, that's an impressive number. But all the math works out, and we've tested it. Now, what does this mean to you? Well, let me get this all back together, and we'll go from there. All right, so we've got our NanoVNA here, okay? And the NanoVNA is important because we're going to use the NanoVNA to test our little device here, okay? First off, we got to do the most important thing. We're going to be eventually hooking a radio to this, so we need to verify that the SWR on this is going to be good. Okay, so where do we start? Well, let's go ahead and turn the device on, and we're going to go through calibration. So I'm going to zoom in here to show you guys calibration, all right? And let's see, that's a pretty good start right there. And I'm going to see if I can get this just in a little bit better focus. Hold on. Okay, so with a little bit of adjustment, that's a little bit better. Looks like good focus. I can read it well enough to do this. So we're going to go through calibration. So first off, I want to decide what am I actually going to choose to calibrate for, right? So that basically means that, well, let's start. I want to change a couple things, right? I'm going to change my display slightly, make sure I'm in the right format, which I am. And let's take a look at my scale. And I'm going to want to show values. Let me go back on that and take one more look at that. Dev scale. Okay, so I want my my dev to be 1. We'll start with that. Okay. Now let me take a look at bottom is 0, top is 8. That's fine. Reference position. I'll make it. Let's see if I put it in 1. I'm going to put it down here. That's where I want it. All right. And then I want to show grid values. There we go. All right, so there we are. 1, 2, 3, 4. That's what I want. Now, what frequencies do I want to check? And a lot of this comes down to, okay, exactly what am I going to be using this attenuator for? Am I going to be using it for, I don't know, just HF? Or am I going to be using it for a lot more? So let's take a little bit of a look at that and kind of see what we've got, because that's an important question, right? So I'm going to just say, all right, I'm going to go back and I'm going to go all the way back like that. And I am going to go to my stimulus and I'm going to start at 1 megahertz. And then I am going to go all the way up to, let's go up to 30 megahertz. Okay, so I'm going to do a pretty broad sweep here. All right, so with that, I am probably going to want to do a calibration here. So we'll go to calibrate, and I am going to reset my calibration, and I am going to select calibrate. And it asks me to calibrate open first, so my ports have nothing on it. Let's hit open. And it goes across the top. See, barely see that blue line, but now it's done with open. The next is short. And again, I am dealing with the port 1, so I am going to put the short on here. This is just a short I made because the other one, it was so hard for me to tell. And you have to excuse me, I've got to get underneath this thing a little bit. There we go. All right. It basically is a short that I made. It's from just a regular old coaxium that I put together. All right. And that was just because it was too hard for me to find the other one all the time because it was so tiny and it was difficult to see inside it to see if it was a short or not. I've selected short, and short is complete. Now I need to put a load on it. So I'm going to use one of these, right there. That is a 50 ohm load. We'll apply that like so. And then we will click on load. There. All done. And now it wants the isolation. So what the isolation is it is a second 50 ohm load that's going to go on port 2. Now we could stop right here because all we're setting this thing up for is SWR right now. But let's go ahead and go through the whole thing. And I'll go ahead and do isolation. There it goes. And you know, when you buy your unit, it does not come with a second load. You have to get one. So be aware of that. All right, so now we're going to do through. So I'm taking both these off. And excuse me if I go in and out of shot here. This is a pretty tight angle. And we're going to just put the through in, and this is nothing more than just a coax cable, right? We're going to attach it on one side, and we're going to tighten it on the other here. Make a good through, like so. All right. Then we go back to our menu, and I'm going to click through, like so. Now, I can either save this in RAM or I can save this on in a save setting. I'm just going to say done in RAM. So it's calibrated now in RAM. Now I'm going to back the camera back out. And let's see. Whoop, wrong direction. All right. We're going to zoom back in a little bit, but I need to set up for my test. My test is kind of interesting here because we're actually just going to be going into one side of this with a good dummy load on the other side. So let me grab that dummy load. All right, and I bumped some stuff around, but here's my dummy load. This is just a very, very low voltage, basically a DL30A, which is theoretically 30 watts for a very short period of time, of course. I'm going to put that on one side. I'm going to attach this adapter right here on the other side, like so. Then I am going to hook this right here to this. And then we are going to zoom in and take a look at our as you can see, hopefully, we're right down here on 1:1. Really nice. And it shows that our SWR is 1.037. And again, that's from 1 megahertz to 30 megahertz, right? Now, we can get more creative and we can take a look, and I think we should just quickly glance at what this would look like from 30 to, let's say, 300, okay? So let me stop, and I'll set that shot up and get it all set to go. All right. So you're going to have to take my word on this because I know I'm not showing it to you, but we have actually recalibrated this thing from 30 megahertz. Let me get my little pen pointer here. 30 megahertz over here to 300 megahertz right across here. And we're still right there at one. Looks like our highest side is up there. I am going to move my marker on over to the end over here. And we can see at the high side up here, it is 1.1 to 1, almost 1.2. That is more than acceptable. So it is going to be safe to hook a transmitter to this, okay? Now, we need to see, though, is if it's actually dropping 50 dB. So we're going to need to change our setup a little bit on our device here. So I'm going to go ahead and let me pause the camera and we'll set up for that. All right, so we changed our setup a little bit. Not much, but we're actually coming out of port 1 into the attenuator. The pass-through on the other side, we've got the dummy load, which, by the way, I misspoke. I said 30 watts. It will only handle a persistent 15 watts, okay? It'll handle 30 temporarily, and as a matter of fact, I'm told it'll handle 50 temporarily. However, yeah, your mileage might vary. I have bigger ones that I typically use when I'm testing radios. Now, I'm coming out of the attenuator port, and I'm going into port 2, okay? So I'm going to get this all kind of back in a shot where we can take a look at the actual device here. Let's see if I can get the zoom right so we can see everything. I'm a little too close, wouldn't you know it? Let's see, am I better? I'm going to go out just a hair more. There we are. All right. Okay, so now what I need to do is, now we're still in SWR mode, and you notice I'm set now for 1 megahertz to 30 megahertz. I need to go in here and let me get my big fat hand out of the way, and I am going to go all the way up to display, and I'm going to click on my format, and I'm going to change it to logmatic, and then I'm going to go back. And what do I see? Okay, so what I see is, of course, my camera drifting. What I see now is I see my 0 line up here, and then I see minus 50 dB over on this side, okay? And if I take a look at my measurement up here, it's saying that I'm at minus 50, almost minus 51. Let's adjust our cursor here. We'll take it over to, oh, let's go to the middle of this. What the, oop. That's one thing about these little test things, is it's really difficult to maneuver in them, and it takes a little practice. So don't be surprised if menus pop up and stuff like that. So actually, right there at about 15 megahertz, we are just slightly under 50. Okay, and this is what we want. This is the kind of attenuation we want, right? Why is that? Well, let me back this out again. Don't mean to make anybody seasick, but when you push power from a radio in here, all right, let's say that you were pushing 10 watts in here, okay? So when you're pulling out 50 at 10 watts, well, what does that give you? That gives you minus 20 dB coming out of the hole here, right? Or excuse me, minus 10 dB coming out of the hole here, all right? If you're pushing 50 watts through here, it gives you a little under minus 3 dB coming out here, okay? And oh my goodness gracious, if you're pushing 100 watts through here, you're putting out just about 0, okay, dB. Now, the tinySA says it supports up to 10 dB. This will probably take care of just about anything that you decide you're going to hook to it. But bear in mind, okay, you have to verify where it actually is as far as dB as you go through different frequencies. Now, we're just looking at one setup. Let's take a look at the other, and I'll show you how to get there. Since I've already calibrated this, and I'm not a huge fan of not recalibrating on these often. However, we're kind of just looking at getting close here for this little demonstration. So, okay, I'm going to come out just a hair. A little hard to see, I know. There we go. All right, so what I'm going to do is I'm going to pull my menu back up, and I am going to do a recall, and I have saved my 30 to 300 megahertz setup, okay? And I see that the calibration is fine there, and I can look, and there is our SWR setup, which is really good, okay? Now, you notice I haven't changed any of the hookups, but since I've told it that I want to be in SWR mode, then it understands that. Now I need to change this to logmatic. And that's quite interesting, isn't it? Take a look at that sweep, right? So as I get into the higher frequencies, I'm getting more attenuation. And let's go ahead, let's move our marker over here, if we can. Let's see if we can get our marker over to, how about 146 or so? Okay, so 146, our dB attenuation's quite a bit higher, right? Up here, our dB attenuation is showing 57 dB. Now, is that super accurate? Well, I'm crossing a big border here, okay? If I went to a tighter angle, it could be tighter yet. But we know that it's more, not less, and we know where it is, so we've got a rough idea where we can do our calculations from. All right, so we've now tested our unit all the way up to 300 megahertz, okay? Will it do more than that? Well, yes. However, it's not going to be stable across all of those frequencies. Now, you notice if I was here and I was testing my 2 meters, right? I'm right about in the same spot, right? All the way through the 2 meter band. And we can show that real quick. I'll go ahead and set up for that, and we'll show it to you in just a second. Now you see I got to get my math straight. So if 146 is the center, it's 142 to 150. Okay, so that looks really good, right? 1 to 1. Now let's change our mode. Display, format, logmatic. So that tells us that's pretty much across the board right there, right? We're at about 56 to 57 dB. Attenuation. Now, we want to take as much as we can away, but we want a little bit of stability in that, right? So, again, this looks really good. What if I was testing a 440 or a 220? You just would set up to adjust your dB to that. Now, what about adjusting your dB so those numbers make sense to you, right? Let's look at that using the tinySA. Well, all right. Yeah, okay, I lied. This is an Ultra. The tinySA works. It works really well, but the Ultra works better. The Ultra has better coverage. The Ultra has better bandwidth resolution. And just all around, the Ultra is a better choice. Now, you're more than welcome to buy the Tiny SA standard with that 2.5-inch screen, but this 4-inch screen is really helpful as well. Okay, so what we're going to do is we're going to do a calibration. Here's kind of our test setup, all right? So we're going to we want to go ahead and get the attenuator configured in for our device, basically, okay? So what we're going to do is we are going to, first off, calibrate the tinySA, and then we're going to hook it up with, believe it or not, another tinySA, and we're going to use this as a frequency generator, okay? And we're going to have it generate a frequency so we can calibrate the offset. Then what we're going to do is when we're all done with all that, we are going to hook a radio to it so you can see what it looks like when everything's properly configured. Okay, so to get started, all we're going to do is we're going to run the cal port, which is the top port on the Ultra, to the RF port, which is the bottom port on the Ultra. Okay. The difference between one of the main differences in hookups between the Ultra and the regular SA is that it does not have a low and a high, okay? It only has the one port, okay? It also handles a lot higher frequency, so I cannot begin to tell you how important it is for you to consider when you're purchasing this to buy the Ultra, okay? Enough of a sales pitch. Let's zoom in on this. best we can, getting the entire screen in. Focus is, let me pause, see if I can get a better focus. All right, so that's a little bit better. So let's go ahead and get this in calibrate mode. So we're going to go to configure, and we're going to do a level cal. And we're going to calibrate 100 kilohertz to 500 or 5.3 gigahertz. Okay, so there we go. I'm going to say calibrate me. And calibration complete. All right. Okay. Now, I am going to hook this up, and I'm going to show you how it's all hooked up. All right, so stand by. All right, so I am going to set this up to be able to properly read information on it. So I'm just going to give you a general overview. I have an tinySA here, a tinySA Ultra here, which is going to be my frequency generator. It is going to go in, just like the radio would, into here with this 50 ohm dummy load. The attenuated value of what it's sending out is going to go out through here, around in this cable right here, and then it's going to show up, and it's going to hit this. And what this is this is a DC filter. It will not allow DC to pass into the tinySA. Now, there is a capacitor in here to strip DC here, and I'll put up a picture here. Now, what we're basically trying to do here, though, is this is just to cover our you-know-whats, just in case that capacitor fails, okay? And I have had little capacitors fail before, and it can really raise some havoc. So, important piece right here, all right? Also, we are going to disconnect this while we're setting up our output, okay? Just to confirm that we have our output right on this, okay? So let me change the shot a little bit, and we'll come back to this. All right. So we are looking at the tinySA that is going to be used as the frequency generator. So I am going to go into mode, and I'm going to say signal generator. And now I've got a whole mess of fun things I get to set up. Now, really important to remember, okay, I have disconnected the other SA from the attenuator. I don't want anything to go out to my other SA until all the settings here are what I know and where I want them, okay? Now, so what I'm going to do is I want to set my frequency. I'm going to set it to 146 megahertz. All right? Now, I am going to set my dB level, and I want to set it to -20. There I am, okay? So, I'm now at -20. Actually, that should be good. Oh, and one last thing. I want to turn the output on. So I am now pushing out on 146. All right, moving on. Okay, so now we need to set this to -10, right? So I need to go in here to level, attenuate, manual, and just put 10 in. And there I go, and it indicates that up here in the corner, okay? Now, we have our unit on, and we have our unit at a 20 dB. So let's go ahead, and we are going to go back back, we're going to go to frequency, and we're going to do a 0 span. All right. So we're going to set 0 span for 146 megahertz, like so. Now we're going to hook up to the attenuator. Okay. Now what we're also going to do here is we're going to change our bandwidth. We're going to change our real bandwidth. Let's go to 3K. Okay. Yeah, that's not bad. Actually, might be a little too hot. Let's go to 1K. All right. So, what I want to do here is I want to center my marker. So, I click on marker, and I'm going to say modify marker, tracking. No, okay, I want to turn tracking off. And then I want it to be at a certain point. So we'll take it back. And now I'm going to use my little wheel here to move the marker kind of to the center so I got a general idea. Now, the number I'm seeing up here, 78.3 dB, right? So, what do I want to set my offset to make it right? Now, I know that I'm putting out minus 20 dB, right? So I need to take 20 from this number. I'm going to say that my attenuation here is 58, right about 58 dB. So, if I go here to level, and I go to external gain, if I put in minus 58, look at where I'm at. Look at where I'm at. I'm at 20 dB, 20.3 dB. Now, all that's left is to hook the the HT to the attenuator. Let's go ahead and do that. All right, so what have I done? I have hooked up this Yaesu radio right there. And here's all the rest of the stuff. All I've done is I have swapped out the Yaesu radio for the frequency generator or signal generator that I was using coming out of the Ultra. We're going to have a conversation about the frequency or signal generator that you're using and some of the reasons that I prefer to use the Ultra for that. We'll talk about that, and it's just spec differences. All right, so I've gone ahead and set my start, my stop, and my center frequency, okay, to examine 146 megahertz. We've got our dB scale over on the side over here, and my marker should just jump up to the highest point, which it did. And I have, what have I got? 37.8. So 37 dB. Well, for those of you playing at home that don't want to do the math, 37 dB outputs 5 watts. This is a Yaesu FT60, which on high power puts out 5 watts, so that worked. What else can we play with this? Well, what I want to show you next is a very important test you're going to be interested in, okay? Now, we need to have a little more knowledge, though, of how our unit actually spans out, okay? So we can do some decent tests. And I will go through in a longer video on how to do this really correctly, but for this one, we're going to kind of run with our current setup, okay? And what I'm going to do is I am basically going to come down here to measure, right here. I'm going to select measure, and I'm going to select harmonic. Our frequency fundamental is 146 megahertz. And I can represent a full span on it by doing 0, or I can bring this down to, let's say, let's do 50 kilohertz. All right. Now, let's key the radio. Now, what I'm looking at are these numbers on the side. I'm looking at 20. There we go. Okay, now I paused it. This allows me to take a closer review of these numbers. So, I can see 2 is, again, the offset of the principal. So 3, though, is what we want to look at. So our principal is putting out, right here, 37.4. So our principal frequency is 5 watts of power. 3 is the first harmonic, and it is minus 53. Okay, so that means there is a 53 dB difference between these two. Now, I'm going to subtract the 37 from 53. Okay, and what is that going to give me? Well, that gives me 6 and then 1. So that gives me about minus 16. Minus 16 is acceptable for this operation. So technically, if that's the highest one, this passes. Now, I will tell you that that third harmonic is a lot less, okay, than you might think, okay? So just kind of bearing that in mind. But with that, okay, we have the numbers that we're looking for. Anyway, that kind of covers how to set up your attenuator. I'm going to have a more advanced look at this using a better, I don't want to use the term better, but it is. It's a better unit to be able to do these tests. And I think you want to stick around for that one, which should be coming out pretty soon. Anyway, there you go. Well, there you are. I make a statement in the video talking a little bit about how those numbers for the harmonics are a little off. And to explain that better, I'm going to do another video. The reality of it is that when we first started looking at this attenuator here, what did we see? Well, what we saw was that the variation was a curve, okay? And that curve goes all the way out into the 700-800 megahertz range. And you need to take that in consideration when you're actually checking those harmonics. I'm going to show you how I figure out how to do that in another video, utilizing different equipment. It's the same thing that we did here, but it's just going to be different equipment that we're using that's easier to film, okay? With that, hey, I hope it helps. I hope you learned something. And with that, this is Stu, AG6AG, saying 73, and hoping to hear you on the air.